Good evening, everyone. My topic is prospects and trends in machine learning capabilities. Let's dive into the topic. This is the agenda. Uh, as an intro of machine learning, we have certain questions to be asked. How computers can learn, how the computer acquires knowledge, how the computer gains experience from the prior or past performance. The answer for all these questions is the machine learning. The machine learning is something, a field of study that gives the computer the capability to learn and improve from experience without being explicitly programmed. So, as a quite formal definition given for a machine learning, most of the people are knowing about it. It's a field of study which makes a computer to learn and improve its experience without being explicitly programmed. There are different types of machine learning algorithms. Initially, it was a two, later, it was extended to three. Now, it is four. Beyond four, in deep learning, we have a one more additional kind of learning, and this type of learning is keep on increasing it day by day because of the applications and the evolution of the data. And coming to the basic types of machine learning algorithm, so it starts with the supervised. Supervised learning algorithm deals with a labeled dataset, whereas unlabeled dataset is dealt in unsupervised learning. Semi-supervised is an intermediate between supervised and unsupervised, and the reinforcement, there is no training dataset is required. This is the difference between these types of machine learning algorithm. So coming to the supervised learning technique in detail, this learning technique is commonly used in application where we have a predictive modeling. The predictive modeling is nothing but it's a statistical technique that can predict the future outcomes with the help of historical or a training data. So mostly it deals with the labeled data set. That means the input data set, it has some target attribute, which is nothing but the label, where in the step of classification, which that attribute has to be predicted. So when you see this diagram, you have a data set which is having a labels for each and every record. So using this data set, the model has been developed. Once the model has been developed, model has been trained, you are giving the model for a test or an unseen data set to predict the class label for a data set. So this is a layout of a supervised learning. You have a label data set. Label data set in the sense is every record has certain labels. And once this label data set is provided to the machine learning model has been developed. With the machine learning model, the test data or unseen data set is provided to the model to get up with the predictions, whether it be predictions of the categories. So the two basic supervised learning tasks comes under a supervised learning algorithm. One is classification and regression. So classification, the difference between classification and regression is both are doing a prediction job, but classification predicts class labels, whereas regression predicts values, numerical values. So classifications, the result of classification are discrete form, whereas the results of the regression are numerical values which are continuous in nature. So commonly the SVM, naive-based, decision tree, logistic regression, all these algorithms comes under a classification type, whereas a linear regression, multivariate regression, regression trees will come under a regression type of supervised learning. As we go into an unsupervised learning technique, any application which requires a descriptive modeling can go for unsupervised learning. Descriptive modeling is nothing but it's a mathematical process that describes the real world events and the relationship between factors responsible for them. And mostly this unsupervised learning uses an unlabeled data set. Unlabeled means the data set without any labels. Okay, you have attributes. The final target attribute is not present in this kind of data set. Whereas the algorithm, the ML algorithm has to has to model the relationship among the attributes, and later it has to be labeled. So see that this is an unsupervised learning. You have an initial unlabeled data set. Okay, you don't have any categories or classes. You have each record is of different from another record. Once these different data set without any target attribute is being fed into the machine learning algorithm, the machine learning algorithm based on the similarities and the differences, it will try to group the records, and later the label class label is assigned to a group. This is a unsupervised learning framework. Under this unsupervised learning algorithm, the quite normal task is clustering and association rule mining. As people who are familiar with data mining, they may come up with these words, clustering and rule mining. Clustering is nothing but the grouping of input data set into different classes or categories based on the similarity. Whereas the association rule mining is a very common technique used for market basket analysis. Okay, which this technique used to mine and extract the rules or patterns from data set. The rules is nothing but which will explain the relationship between different variables or attributes of the data. The quite normal algorithm under a rule mining is a priori frequent pattern growth algorithm. These are coming under this group, whereas k-means, k-midoid are all examples of a clustering algorithm. So when we deal with the semi-supervised learning, as the assumption that I rushed up with the supervised and unsupervised, because most of the researchers or most of the people who are dealing with data mining, data analytics, data, so that's why I rushed all these topics, and I try to explain what is semi-supervised learning technique in detail. And in addition with that, there is one more technique which comes under deep learning as self-supervised. I'll take with a lot of examples. I'll spend some time on explaining a self-supervised. So semi-supervised learning technique lies between, it's a mid ground between the supervised and unsupervised learning. Here, the training is done with the training data set. In the training data set, a very small number will be having a label, and a large number is with the unlabeled inputs. From this combination, the model must learn and make predictions on new examples. So we'll see that. So see the flow of semi-supervised learning. So you have a labeled data set. Labeled data set is nothing but an input data set which has a target attribute. Okay, that's called the labeled data set. So this labeled data set is used to train the model. Once the model is trained with a small amount of labeled data set, once the initial training is done, the pre-trained model is used to over the unlabeled data set, which are large in number. Okay, so once this model is applied over this unlabeled data set, which are large in number, the model will able to predict some labels. That label we call it as a pseudo labeled data set. Pseudo means may not be a perfect one. It's something an intermediate label. Okay, so that's a pseudo labeled data. Okay, so later once this process is over, all these are done in pre-training. Once this process is over, we have a pseudo labeled data set and the labeled data set. We are combined together, and finally what we are doing it again, we are doing a retrain. Again, the model has been retrained with a combo of pseudo labeled and labeled data set. Okay, so this is our target model. This is what happened in the semi-supervised learning. We need to question is how semi-supervised learning is dealing with the data set which doesn't have a label. This is the step. Okay, initially the model has been trained with the labeled data set. With that pre-trained model, again it is applied over an unlabeled data set. We get a pseudo label. So again, the same model has been retrained with the combo of pseudo labeled and labeled data set. So this is what happened in the semi-supervised learning. Okay. So coming to the fourth category is reinforcement learning. Reinforcement learning is a learning algorithm which doesn't require any training data set at all. without any training data set, the algorithm will be keep on monitoring the environment in an iterative fashion. Algorithm is also called as an agent. When we speak about the reinforcement learning, there are some catchy words they are using it. Agent is a word commonly used. Agent is nothing but our algorithm, ML algorithm. Okay, this algorithm will be continuously learning or observing the state of an environment. Based on the state of an environment, it does some action. Okay, according to the action, the system may receive a reward or it may receive a reinforcement. Based on this, it will keep on adjusting the actions. So this is what the reinforcement learning. So this is an example to understand the reinforcement learning. How do we balance the stick on our hands? So based on the position of the stick, we'll adjust the hands. So we'll adjust the hands, the position of the stick will be changed. So this was a perfect example for reinforcement learning. So see that this is what explained. So agent is nothing but our ML algorithm. This ML algorithm will keep on monitoring the state of the environment. The state of an environment is being monitored by the agent. Okay. So the based on the state, in the algorithm, there will be some decision-making function. So using this decision-making function, the action is performed. So once the action is performed, the agent receives a reward or reinforcement from the environment. So this is how the reinforcement learning has been performed in the application. There are many applications which uses a reinforcement learning. Most of our games, video games, robotics, all are using this reinforcement learning. Because we don't have a training data set, even the training data set is not useful in learning an environment. Environment is keep on changing it. Okay, so the reinforcement learning is very so connected to the applications. Application AA application. So realistic. It has some realistic connection to AA applications. So there is also a discussion regarding a machine learning and deep learning. What is the relationship between machine learning and deep learning? Is both are same? Is both are different? So do we have a lot of doubts as a student as well as a researcher? We need to know, do we apply a deep learning algorithm or do we apply a machine learning algorithm? Is our project belongs to deep learning? Is our project belongs to machine learning? Is deep learning is a subset of machine learning? So we need to know the relationship between that. So machine learning as well as the deep learning, both are children of the AI. So machine learning is a children of AI, whereas deep learning is a grandchildren of AI. That's the relation. Okay, both are the children of AI. Okay, whenever you have a data set which is of whenever your data set is very small, you can manage with your GPU. You can do your training process with your hardware requirements. Whatever hardware requirements you have it, you can apply a machine learning algorithm. Whereas you cannot manage your data set and you are supposed to do a regressive training process where it requires a specialized GPU. Okay, your ordinary computer cannot afford for executing all your task of your application. Then you can go for a deep learning technique. That's the difference. Okay, so machine learning can train on smaller data sets, whereas it requires deep learning requires large amount of data. The human intervention is required to correct and learn. So this is a very important line, which is the only difference as far as concerned with machine learning and deep learning. The slight difference between machine learning and deep learning is this is the line. So machine learning requires a more human intervention, whereas there is any human intervention is not at all here in deep learning. It learns on its own from environment and past mistakes. Okay, so whereas the machine learning requires a shorter training and it ends up with lower accuracy, whereas since it has dealing with a large amount of data set, deep learning has a lengthy training process and it ends up with a higher accuracy. It makes simple and linear correlations, whereas it makes a non-linear and complex correlations. These are the basic difference. I want to explain this line. Okay, so this lines is a difference between a machine learning and deep learning. Machine learning requires more intervention, whereas it learns on its own from environment. Applications uses a supervised learning technique, semi-supervised learning technique, or sometimes it could be unsupervised. Whereas deep learning is additionally one more learning technique it is using it. We'll see what does that one more extra learning algorithm we have in deep learning. Okay, that's the difference. It learn on its own from the environment, past mistakes. So either it may be a reinforcement learning, but beside reinforcement, there is a one more additional technique technique we have it in deep learning. So we have a lot of question: is deep learning is supervised, unsupervised, or what kind of learning it is there in deep learning? So it has a supervised, it has a unsupervised. We have a concept of unsupervised, whatever we learn in ML. We have a semi-supervised, the same concept in ML is there. We have a reinforcement neural network is also there. And the one more additional component, which is quite normal, trendy component is the quite trendy component is self-supervised component, which is which adds a powerful for deep learning, which adds more power to deep learning. Is there any?
Ma'am.
Ma'am, there is an audio issue, ma'am. Mic.
Ma'am.
Ma'am, there's an audio issue. Some sound is anonymous sound.
Okay, ma'am. Okay, ma'am. We will check out that.
Okay.
Is it okay, ma'am, now?
Oh, okay. Some mic or
Okay,
something is on, I think.
Okay. Sorry,
Okay.
ma'am. Sorry for the interruption.
Okay. So one additional component which makes deep learning so powerful is self-supervised. Okay. So all these kind of learning techniques is possible in deep learning. It mostly depends on how you design a neural network or how you are going to use your neural network for your application. That is the difference. Okay, you have all combinations. I think the people may be familiar with a few deep neural networks. Have you heard about ANN, CNN, RNN? Is the audience? My question is audible. This buzzwords. Have you heard this ANN, CNN, RNN? Most of. Have you heard this ANN?
Yes, ma'am.
Yes, ANN is artificial neural network. CNN is
Conventional
network. RNN is recurrent neural network. These are any researcher or any student who are speaking about deep learning, they slightly jump into a CNN, RNN. Okay, for the image classification, object detection, face recognition, speech recognition, sentiment analysis, for doing all these applications. Suppose you want to classify the image, or you want to detect an object or a face recognition, or you want to do some sentimental analysis, you either have to design a CNN or RNN or ANN. All these neural network, deep neural networks, which is coming under a deep learning, are using a completely labeled data set for training data set, which comes under a supervised deep learning models. Okay, these are all supervised deep learning models. Similarly, there are certain neural network models, autoencoders, cognon map. Cognon map is a self-organizing map, which is for which is used for certain applications, color coding, image encoding, word embedding. So these are the applications where we use certain deep neural networks, which follows a unsupervised deep learning, which means that we may use a training data set without any labels. Okay, so based on the relationship between the attributes, it will try to code it. It will try to do image encoding or word embedding. So which comes under a unsupervised deep learning. So there is another famous DNN, which is a deep neural network. It's a generative adversarial networks, GAN. GAN. Most of the people may heard this word, GAN networks, GAN. So GAN is an example for the fantastic example for semi-supervised deep learning, which means that this GAN network uses it will produces the images based on the text description. When you give a text description, it will give you the images. So most of the search engine, when you give a text, you give a query no to get an image, you will get an image. So video prediction, all these are using a certain deep neural network which follows a semi-supervised deep learning algorithms. And deep reinforcement learning is also there. Certain networks, deep neural networks, is using a deep reinforcement learning. Okay, so the robotics, video games is using a reinforcement learning called a Q learning algorithm, which is using it. So the neural network which uses a Q learning algorithm, which comes under a category of reinforcement learning. So up to which, what I am trying to explain is, whatever the learning algorithms, the basic learning algorithms which is there in machine learning, the same is applicable in deep learning to form or design a neural network. Okay. So it's up to which, how do you understand, how do you perspect our application and design the neural network in deep learning. So the one more thing which adds a power to deep learning is self-supervised learning. Okay, this is the capability which is a new trend in machine learning capability. So which is it's a self-supervised learning, which is commonly used in deep learning network. Okay, deep neural networks. So we need to know what is self-supervised learning. Self-supervised learning is a machine learning process where the model trains itself to learn one part of the input from the another part of the input. Usually in semi-supervised or unsupervised, the system learns the input, learns from the output of the learns the input of the second step from the output of the first step. Whereas in self-supervised learning, the model trains itself to learn one part of the input from the another part of the input. Okay. Yeah. It identify any hidden part of the input from any hidden part of the input. For example, it may predict the future from the past. It may predict the future from the recent past. It may predict the past from the present. It may predict the top from the bottom. So, for example, you may have a sentence. You may have some sentence as an input sentence in which certain portion may be hidden.
Wow, listen.
Sorry, ma'am, for the interruption, ma'am.
Okay. Certain portion may be hidden. So with the unhidden content, the hidden you are going to identify the hidden part of the input from the unhidden part of the input. That is the predictive or a pretext learning. So this is a quite normal learning which is used in most of the applications in computer vision and NLP. That's what my plan to discuss in this session. Okay. I think I'm boring you. Are you in the line? The audience, are you able to follow me?
Yes, ma'am, they are following me.
Okay, ma'am.
No, I'm following.
Okay, thank you. Okay. So coming to this we need to know what is the difference between so-called unsupervised and self-supervised. What's special in self-supervised is unsupervised, as I already discussed, is in unsupervised we don't require a label data set. Similarly, we don't require a label data set in self-supervised. Okay. So without labeled data set, how we are doing a supervisory task like classification and regression. That is the fantasy behind the self-supervised. Okay. So in unsupervised it does not have any feedback mechanisms, whereas during the training process, the continuous feedback mechanism is there. Okay. So even though it is using unlabeled data set, even though it is using a unlabeled data set, the continuous feedback mechanism is being obtained during a training process as a supervisory signals. Okay, the self-supervised is used for regression and classification task, whereas unsupervised is used for clustering and dimensionality reduction. So this is the highlights of self-supervised. As similar to unsupervised, it is not using a labeled data set, and still it is doing a classification and regression task. That's a highlight. Okay, why do we need a self-supervised learning? Is because getting a complete label data set is costly and it's a lengthy process, and normally connected to generic AI. Self-supervised learning framework is more closer than the supervised learning framework. Because of these reasons only, we are going for a self-supervised learning technique. Okay. So we'll see certain applications in self-supervised learning application in computer vision and NLP. Is anyone doing doing a research work in deep learning? Deep learning? Is audience, I'm just to know, or is anyone are working with deep learning, or anyone encounter certain basics of deep learning? Audience, is anyone there to answer my deep learning?
No, ma'am.
Deep learning, you don't have encounter the word deep learning. You're not doing a research in deep learning, or at least any idea about deep learning, just to know it, because
Yes, ma'am. We know about the fundamentals of deep learning, ma'am.
okay, very good, ma'am. With the assumption that I'll take it for a majority, because when I speak on something on deep learning, it should not be Greek and Latin for the audience. That's why I'm asking it. Okay. Have you heard the word BERT? BERT, B-E-R-T, BERT.
Is it a bidirectional encoder?
Yes, madam. Because I need to introduce that BERT also. That I'm not giving a complete picture about the BERT. Okay, I'm just introducing what is BERT and how important BERT in deep learning. How what is the connection to self-supervised learning in application in computer vision. In the computer vision, we always deal with the images. Most of the images doesn't have a labels. Okay, so very few images have a label. So in that category, in the computer vision, trying to get a label for a data set, or trying to get a description of an image, which follows a self-supervised learning technique. Okay, so which has a 2 stages in training, as I already told that since it is using a training data set without any label, you cannot make your model perfect in a single stage, in a single step. So you have to do several steps to get a perfect trained model. Okay, so initially the first task in computer vision is, self-supervised learning in computer vision is, you have a data set which contains of images without any label for these images. So once you fed in this images to a without label into a model, model will try to learn the similarities between the images, input images. It is not trying to find, it is not trying to map input to the output. It is trying to connect the, learn from the training data set itself. Okay, which means that it is trying to predict the hidden portion from the unhidden portion. Okay, so that is called the, that is why we called as it's a predictive or pretext learning. Okay, so it based on this, it is trying to come up with some kind of intermediate labeling, which is called as a pretext task. So we get some kind of, even though we don't get a, we will not able to get up with a perfect labeling it, we'll get some kind of description for the image. We call it as a pretext. This task, up to this task, we call it as a pretext task. So this pretext task, we call it as a pre-training. This pre-training help or guide the model to learn an intermediate representation of data, which will be very, very useful in understanding the underlying, the beneath structural meaning of an image or a data set. Once this pre-training or pretext task is over, the second step is downstream task. The downstream task is nothing but it's a knowledge transfer process happens. So whatever the knowledge which is obtained in the first stage is moved to a second stage. Now the data set comes with a label. The label means not a perfect label, some kind of description. It is having it. So initially it doesn't have any description, no label at all. And it has a pretext in the first stage with a pretext texted data set. Now this data set is fed into a target model to get a final trained model. So this is how the image identification or a image description or a prediction which uses self-supervised learning.
Madam, please continue, please.
Yes, yes. This is how the self-supervised learning is happen in computer vision. So this is a very quite normal application we could see in in the Google search engines. So patch localization. So this is also a self-supervised learning application. Okay, when you see these two images, see that image, the first image, I think if we are able to identify, it's an image of a cat, the portion of the nose of the cat. And where do you place this second image out of this 8 boxes? Any guess? Where do you place the... So when you see this image, you could see it's an ear of the cat. So definitely it could be the top left corner. This is the place. As a human, we can understand the shape and structure of the image. So we can easily place it. Whereas when it gives to, when it is for a mission. So see the second question. It's something, this is the first image. So whenever you take a first patch of your image, first patch you should always place in the middle. And when you take a next patch, you have to find the similarity between the 8 different positions. You have an 8 neighboring positions for the middle. So you have to find, when you take this patch, you have to find the similarity between this patch and this patch, I mean this position and this patch, this position and this patch. And based on the similarity, you have to place it. Actually, this is a classification task. So I was explaining to understand this is a classification task which is using a directly or indirectly self-supervised learning technique. Okay. So coming to another application, this is all the very, very famous applications in computer vision. Coming to the training coming to the NLP, there are certain applications in NLP which uses a self-supervised learning. Is a next sentence prediction, NSP. Next sentence prediction is very, very important because we need to predict the sentence based on long-term contextual dependencies, because we are in social media era. We need to keep on predicting what could be the result of, suppose I think in next before 15-20 days, we need to predict which country is going to win FIFA 2022, and who will be going to win in a Gujarat election, and who will be, so everything and everywhere we'll be keep on doing a prediction from the sentences. Either it is a Twitter post, or it may be a Facebook post, or it may be a messages in the WhatsApp, whatever it is, or whether it is a mail, whatever it is. Based on this, we need to understand and we need to find the dependencies on these. We need to understand the contextual dependencies on these matter. Okay, so the next sentence prediction is a very, very important concept in NLP. For example, when you consider this three sentences, for example, I have given you three sentences. After completing the school hours, Mike went home, and after almost 50 years, the manned mission to moon is finally underway. Once home, Mike watched Netflix to relax. So when you combine the pairs of sentences, which sentence could be the next of which one? Could you able to relate it? Is sentence one and one is next of two, or two is next of one, or one is next of three, or three is next of one?
Almost next of 3, ma'am.
I mean, one after one. I mean, one. Three should come after one. Out of three should come after one. After completing the school hours, Mike is going home, and once he entered the home, he is watching a film. So it's watching a film. Okay, so this is the next sentence prediction. As a simple, I have given you a three sentence. For a mission, the completely you may have a paragraph, or you may have a document completely is fed into it. You have to understand the contextual meaning. So you may have a paragraph or a document. You need to understand what is the document belong to, what is the dependency, whether they speak about the politics, or they speak about the football, or they speak about the cricket, or they speak about the education, whatever it is. Okay, or which sentence should come after the next. This is a classification task where it follows as a completely self-supervised learning, because you don't have any label for you cannot label this sentence. This is a sentence which belongs to this category. This is a sentence which belongs to this category. So completely self-supervised learning algorithm, learning technique is used in this next sentence prediction. Okay. So the great gold standard developed by the Jacob Devlin in the year 2018 and his team at Google Research Lab. He published a paper on BERT. BERT is it's a gold standard for doing all NLP tasks. BERT represents bidirectional encoder representation for transformers. It is a very, very, very current topic with NLP. The person who want to do a real research in deep learning, they can explore in BERT. This is quite normally Google Assistant. All AI-based chatbots are using this BERT technique. And you have this BERT is supporting a 70 plus more languages in for doing a natural language inferences and question answering. All these NLP tasks are using this BERT. BERT is a deep neural network which follows a self-supervised learning technique, which has some kind of masked language modeling. There is a word which always connects with the BERT as MLM. So it's a novel technique, quite normal. NLP model is before BERT. Most of our NLP model will be following a unidirectional training. Okay, your model will keep on reading your input sentence from either from left to right or right to left, whereas a BERT uses a bidirectional training. Okay, so in the BERT, what the meaning of masked language modeling is, you have a paragraph. Suppose you have your input, which is a 2 sentence or 3 sentence or a entire paragraph, or it could be a document, whatever it is. You will be going to feed this entire document as a single sequence. Okay, in the single sequence, a certain portion of the a certain portion of your words is being masked. The certain portion means according to his research paper, the token should be masked. The reason is to get a better learning by the bird, to get good learning by the bird. So 15% of your input token should be masked at random. Okay, so once you fed all these input statements or input sequences to the bird, once the model is finished, ma'am.
It's already completed, ma'am. Bidirectional encoder. This is completed, ma'am. The next one you can.
Next one.
Yes, ma'am.
Okay, okay.
Yes, ma'am.
So the BERT uses some embedding techniques. Embedding is nothing but converting an entire sentence into a vector. The purpose of making a vector is to do mathematical operation, to understand the semantic importance of a word in a sentence. Okay, that's the purpose of embedding. So there are 3 types of embedding is used in BERT. Okay, we'll see that. This, for example, this is my sentence. Okay, I have 2 sentences. My dog is cute. He likes playing. Okay, so it has to be tokened. Tokenization is nothing but splitting into words. So you may have a continuous sentence, you will be splitting it according to word tokenizer. So here in BERT, they are using a word piece tokenization. So my is a word, dog is a word, is a word, cute is a word. These are all the tokens. This week they call it as a token embeddings. This is a sentence 1. This is a sentence 2. So they labeled as a segment. For example, this is a segment A, this is a segment B. Okay, this kind of embeddings is done in a segment embeddings. Instead of A and B, they make it as a 0 and 1, 2, 3. Suppose you in your document you have 10 sentence means first sentence has India is my country, means India is first token, India is my country. So I have 4 tokens, all belongs to first segment, segment 0. Okay, this is how segment embeddings and the position of each token in the sentence. So this is the 0th token, this is the first token, this is all these the positions. So the position embeddings will tell you the how many tokens, what is its position in the sentence, in the document. So this is all the embeddings they are using in the BERT. Okay, the purpose is all these are vectors. These are all some numerical numbers, vectors, to which will help you to do mathematical operations. That's it. Okay, so your input is always, when you start up any input sequence, you should start up with the special token. Special token, we call it as a classification, sentence level classification token. At the end of the every input statement, you have some separator to distinguish the end of a one input statement. Okay, my dog is cute. This is a one statement. He likes playing is another statement. There is a separator between these 2 statements. And very first statement always starts with a special token, which is called the sentence level classification token. These are some kind of embeddings they are used in a BERT. So the BERT is nothing but some kind of model which is using a self-supervised learning technique. It is trying to learn from the input itself. It is not at all learning from our labeling. It is not at all learning from the output it is going to get it. It's trying to learn something from the input, from some part, something, trying to find the output of some part of input from another part of input. That's it. Okay, so see that, for example, this is a sentence. So this is to be so, this is that to be done. Okay, there are something, we know the answer for this is a computer. That is a word. For example, purposely they are masking a certain words. The purpose is the system has to find the exact, has to predict the exact word for it. Okay, so they are doing some kind of masking here in the input sentence. So there is some connection, some percentage is required for masking it. According to the paper, Jacob Devlin has mentioned that only 15% of the input token words should be masked. You cannot mask all the words in the input document. So you should make only 15% of the words to be masked. Okay, So once this with the masked word with all your tokens, it has been given fed into the BERT. So based on the context, it will keep on learning in both the directions. Okay, it will try to learn from this direction and this direction. So you will try to understand what could be the appropriate word in the mask. It will try to predict the appropriate word. We are not labeling anything about the sentence. So based on the context, it is trying to find the exact word of it. Okay, so the BERT, this is how the BERT is designed. So once this output word, the predicted word is obtained, it is fed into a fully connected neural network layer, and the probability of each predicted word is calculated using softmax. Based on this, we'll be able to find whether there is a contextual dependency between the previous sentence. Is the next sentence is the exactly related to the first sentence or not. So this is how the BERT is working. It's a fantastic, the design of BERT is fantastic. It has a numerous application. When you keep on exploring papers or a research work, you will find out of out of 100 works, 95% of works are connected to the BERT. Okay, this is the design of a BERT. Okay, so this is what the findings as I explored in recent times. BERT has proved to be a breakthrough in NLU and NLU. NLU is natural language understanding. NLP is natural language processing, which is quite normal in most of our intelligent AI applications, especially AI chatbots, even a Google assistants, like everything. Okay, it has shown it has achieved state-of-art results in many NLP tasks. It is also used in Google search in 70 language as on December 2019. Okay, when you compare with today's date, it is exceeding in more number. This what my findings. So this what my ML capabilities. This is a new trend in ML capabilities. Any queries? Audience, is there any queries? Audience? Do you have any query?
Excuse me, ma'am. My name is Priya. So, but my students, they are all working on BERT. Is there any similar tool similar to BERT which we can use in NLP?
Ma'am, there is no replacement. I was asking about one or two expert, ma'am. The people are trained it. Why do you explore a powerful tool other than BERT? You explore BERT. There are various models in BERT, ma'am. The slight variants of BERT, robot, all BERT. There are certain variants. You have a code for BERT also available, freely available code. You can explore on that, ma'am.
Thank you, madam. One more question. The output of it is feed forward. That is FFNN is feed forward neural net with the softmax function. Softmax function.
Yes, ma'am.
So can we use other architecture instead of FFNN and softmax?
Yes, ma'am. We can explore it. I think in that we cannot customize on that area. It seems. If it is possible, you can do it, because finally you are going to do a probability. You are finding that whether it belongs to that next category or not. Okay, you are doing a binary classification at the end. So if you find other possible activation function that can fit your application, you can use it, ma'am.
Okay, madam. Last question. So GAN you have mentioned, no, generative adversarial network. Yes, so every day different types of GAN they are generating. Yes, so what are the different style GAN is there, cycle GAN is there.
Yes, so because everything is open source, means there is no limitation at all. Keep on customize. People keep on customizing for their application. Even I don't know how many GAN networks are there. There are many applications in GAN. There is no limitations. We don't know which has to be used. The only thing is we need to do a trial and error with the existing models. The transfer learning is one of the great gift of this deep learning. We have all these code in the GitHubs. We can use it. If you want to do some kind of customization here and there, and that could works for our application, we can take it as one of the best model.
Okay, thank you, madam. Just
Thank you.
clear. Okay, thank you.
Thank you. Is there any
Thank you,
question?
Nandini madam.
Thank you, sir. Thank you.
It's really a privilege to see you online, madam. After almost 2 years.
Yes, sir. Yes, yes, sir.
And
Thank you, sir.
2020 you're there. Is it right?
Yes, sir. Yes, sir. Every after it's something like again a new wave of corona. After 2 years, a new wave. Okay.
Yes, yes.
In having an online sessions. Okay.
Hopefully, we don't have any fourth wave. That's what people are talking about.
Yes, sir. Yes, sir. Yes, sir. So thanks for the opportunity, and you have been keep on reminding me.
It's really our privilege, madam, actually,
Okay,
to have you
thank
like
you.
this.
Thank you.
Archana, madam, we can please
Yes,
conclude.
sir. Thank you so much, Nandini ma'am, for your immense presentation on prospects and trends in machine learning capabilities. All our participants get awareness of various prospects of machine learning capabilities and machine learning algorithms. Thank you so much, and thanks a lot, ma'am.
Thanks, ma'am. Thanks for the opportunity. Thank you.
Thank you.
Shall I
Ma'am.
leave?
Thank you so much.
Shall I leave the meeting, sir?
Sure.
Yes,
ma'am.
madam.
Okay.
Please.